In this lesson, we're going to learn about isosceles and equilateral triangles and how their sides and their angles interact with each other. Now, if you remember from previous lessons, isosceles triangles are triangles that have two sides that are congruent. So the first theorem and its converse deal with that. The isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles that are opposite those two sides are congruent. So in this case, we have side AC is congruent to side BC. The angle that is opposite side AC is angle 2. Okay, if you go across the center and you see that angle is angle 2. All right. Same thing if you have BC, the angle that's opposite it is that's so angle 1 and angle 2 are the two congruent angles. All right. And the converse just simply says if you have two congruent angles, then the sides that are opposite those angles are congruent. So if angle 1 and angle 2 are congruent, then side DE is congruent with FE. All right. So that's the isosceles triangle theorem and its converse. Copy those theorems down into your notes. The equilateral triangle theorems and postulates that go along with that. Just so remember, an equilateral triangle is a triangle that all three sides are congruent to each other. So theorem 4.3 says a triangle is equilateral if and only it is also equiangular. So if all three sides are congruent, that means all three angles are congruent. And then 4.4 is the corollary that goes along with that if you remember, all three angles on a triangle add up to 180 degrees. So if they're all three congruent, that means all three angles are going to be measuring 60 degrees because 60 times 3 is 180. So corollary 4.4 says each angle of an equilateral triangle measures 60 degrees. All right, pause the video and copy these two corollaries into your notes, and then we'll do several examples. All right, the first example that we're going to look at, we see here this triangle has one angle that we're given that measures 60 degrees, okay? And we also know that we have two sides that are congruent. Well, if we know that all the interior angles have to add up to 180 degrees. If we know one of them is already 60 degrees, that means we know the other two have to add up to 120 degrees. And we also know that these angles are congruent to each other. So 120 divided by 2 is 60 degrees. So each of these angles have a measurement of 60 degrees. So in that case, we can see that this is also a equiangular or equilateral triangle. Okay. The other thing that we could have said is, well, no, never mind. So that's the way that you need to do that. All right. This one is another one exactly the same way. We have one angle that's 50 degrees. So if you have, oops. All right. So if we have one angle that's that's 50 degrees. And so that means the other two angles have to, the cat steps on my keyboard. All right, so okay, so when we subtract that, we end up with 130 degrees. That has to be split up between the last two angles. So, and because we know that if we have the two sides here that are congruent, then the angles that are opposite those two sides are going to be congruent as well. So if you say 130 divided by 2, then we know that that's going to be 65 degrees. So each of these angles here are 65 degrees. Okay? Now on this triangle, once again, we're given, rather than just giving congruency symbol, we're actually given the measures of the sides, and it says find the measure of the side TR. So we want to find the measure of this side down here. This is very similar to that very first example that we had done. So if we know that we're given 60 degrees, 180 minus 60 is 120 divided by 2. So 120 divided by 2 is 60 degrees. So each of these is 60 degrees, which means that this is an equilateral triangle. It's equiangular. All three angles are the same, and so if it's equiangular, it's also equilateral, which means all three sides are the same length. So we know that the length of side TR is 4. Okay? All right. On this one, side CB, okay? So if we know that we're given the measures of two angles, well, so remember, we know that this angle here, the side that's opposite it, is side AC right here, okay? That's this side right here, and it has a length of 3. Well, if we take this angle and bring it across, okay, so that means this is side CB, which we know that is also going to be 3 because the angles are exactly the same. All right. Now on this one, we can see that all three angles are exactly the same. Okay, they have the same measure. That all three angles are congruent. So that means all three sides are going to be congruent. So it says to find the value of x. So we're just going to say 2x plus 11 is equal to 6x minus 9. 6x minus 9. Okay. We're going to subtract the 2x from both sides. 2x's cancel out. We're left with 11 is equal to 4x minus 9. Add 9 to both sides. So 20 is equal to 4x divided by 4. And 20 divided by 4 is 5. So the 4's cancel out on the right-hand side. So 5 is equal to x. So our value of x is 5. All right. Once again, it says to find the value of x. All right. We know that we have a right angle here. Okay. And we know that these two sides that make up the right angle are congruent. So that means angle G and angle E are going to be congruent as well. So we know that angle G is 3x plus 6. Okay. So we know, okay, there's a couple different ways that we could approach this. The easiest way is to say 180 minus 90 is equal to 90 degrees. And then 90 divided by 2 is 45. So each of these angles here are 45 degrees, okay? So each of those angles are 45 degrees. So we know that 3x plus 6 is equal to 45, okay? And then when we have that, we just solve for x. So we subtract 6 from both sides, okay? We're left with 3x is equal to 45 minus 6 is 39 divided by 3. And x is equal to 13. All right? X is equal to 13. All right? The next problem says to find both the value of x and of y. All right? So when we do that, when we look at that, we can see that the two angles here are opposite the two congruent sides. Okay? And so the angle y and angle x are going to be congruent to each other. So if we figure out, okay, so figure out what those two angle measures are, we can figure out the value of x and y. So 180 minus the 52 were already given. So the 8 becomes a 7, 0 becomes 10, 10 minus 2 is 8, 7 minus 8 is, or 7 minus 5 is 2, all right? And bring down, and then 1 minus 0 is 1. So 128 divided by 2 is 64. Okay, so each angle is 64 degrees. Okay, so then we just set those equal to each other. X, if you have 4x plus 20 is equal to 64. Solve for x, minus 20, minus 20. All right, 4x is equal to 44. Divide by 4. Cross out the 4's, x is equal to 11. So x is equal to 11. Now we have 6y minus 2 is equal to 64. Okay, solve, so we add 2, 6y is equal to 66. All right, divided by 6, y is also equal to 11. All right, so that's how you do that. All right, and the last problem that we're going to do in this lesson, we know that we have two angle measures that are 60, so the third one also has to be 60 degrees. Okay, so this is a equilateral or an equiangular triangle. Okay, we also know that the sides that are opposite the angles that are opposite the two congruent sides are congruent, but we know that it's equilateral, so we know that this is equal to 4. So we have 5x minus 3 is equal to 4. We also know that 2y plus 6 is also going to be equal to 4. Okay? So so when we solve that, we're going to add 3 to both sides. We end up with 5x is equal to 5x is equal to 7 divided by 5, and x is equal to 7 divided by 5 is 1.4. Okay, so x is equal to 1.4. All right. When we do the other side, all right. So when we do the other side, we're going to subtract 6 from both sides. Okay, we end up with 2y is equal to -2 divided by 2, and y is going to be equal to -1. Now you might say, wait a minute, you can't have a measure that's a negative value. Well, it's important to notice that this is not the actual measurement. This is just the value of y. If we plug it in, we say 2 times -1 plus 6. That's going to give you -2 plus 6, which is going to be equal to 4, which we already know that the side length there is 4. So the actual measurement is 4. So the -1 is not the actual measurement. The measurement is just the -1 is just the value of the variable that plugs into the equation. Same thing with the x value. You may say, well, wait a minute, I thought it was 4. It's not. This is just the value of the variable, not of the actual length of the side. Anyway, if you guys have any questions, make sure that you answer them, and make sure you copy down those notes at the beginning of the lesson. We'll talk to y'all later.